Hello everyone and welcome back to CodeChef. Have you ever written a SQL query and thought, why do I have to use group by and lose all my row level data? Or maybe you wanted to calculate rankings, running totals, moving averages or percentiles, but the traditional SQL was just not enough? That is where window functions come in. In this video, we will dive deep into window functions in SQL, starting from the core idea of windows and their key concepts, and then moving into ranking functions, analytical functions, distribution functions, and frame specifications like rows between. This is one of the most important and most asked SQL topics in analytics, data roles, and interviews. So make sure you watch this video till the end. Introduction to window functions. Why were window functions introduced? So traditional SQL had a major limitation that aggregate functions like sum, average, count, they required group by. Now group by has certain problems like it collapses rows, and once the rows are collapsed, row level details are lost. But real-world analytics need aggregates and row-level data together. Why? Because sometimes we need to make comparisons like salary versus department average or current row versus previous row, running totals, and so on. So this is where window functions come in. Window functions solve this problem of losing the row-level details. Concept of a window. A window is a logical subset of rows related to the current row. There are some important points related to window. The window is dynamic. Then it changes for every row. SQL does not physically create a new table. It is evaluated after where but before order by. Now, window is not a table. It is not a group of data, but it is basically a logical view of rows. What is over function? The over clause converts an aggregate or analytic function into a window function. It tells SQL to apply the calculation across a set of related rows while keeping each row in the result. Now, why over is needed? In SQL, aggregate functions normally collapse rows and only one output row is produced per group. But over function changes this behavior by preventing row collapse and attaching the calculate value to every row. Basically, over changes result placement, not calculation logic. The function computes the same value, but over decides how and where it appears. Let's understand behavior with and without the over function. So query type, if we are calculating average and then in bracket we are writing salary, so it will give us single aggregate row which will have the average of salary for all the employees which are there in any office or a particular department. But if we are writing average then in bracket salary and then we are writing the over function, then same average is shown on every row. Basically, we are not losing our row level data, we are not changing any logic, but we are just changing the result placement. We are attaching the calculated value to every row. Partition by. It refers to logical data segmentation. Partition by divides the result set into logical partitions, where each partition acts like an independent data set. Each partition is processed separately and does not collapse rows. Now, when to use partition by? It is used when calculations must restart for each group, rankings are required per category, and aggregates are needed per segment. For example, ranking employees per department. So in this example, we will have data of employees of a company. Then in company, we will have different departments. In different departments, we will have different set of employees. So for each department, we need to rank the employees, and that is why we will use partition by here. Then running totals per month. There are 12 months in a year, so every month will have different data. and then for every month we are going to run totals to get the required statistics. Order by in window functions. Now what is the purpose of using order by in window functions? Order by inside over is used to define logical order. It enables sequential analysis and is required for ranking and cumulative functions. This order by does not control final output order. It only controls calculation order. Why order matters? Because if we are not using order, then ranking has no meaning. Running totals are impossible and row comparisons are undefined. Row number function. Row number function assigns a strictly increasing sequential number. It is important because SQL tables are unordered by nature, so row number creates a logical ordering layer. Let us understand the conceptual behavior of this function. It treats every row as unique. Even identical values receive different numbers, and the function is deterministic only when order by is clear. For example, row underscore number brackets over and then in bracket order by salary DESC. DESC is used to order the salary in descending order. Bracket close. Then we have the rank function. Rank function assigns the same number to tied values. Ranking reflects position, not row count. If multiple rows share the same value, first they share the same rank, second, next rank number jumps. So we use the rank function to assign different ranks to the values. Now, specifically the rank function is used for tied values. That means when two values are same, then they will have the same rank, and in that case, if the rank function is giving same rank to two values, then the next rank will be skipped for the next position. The gaps occur because rank reflects how many rows precede the current value. Let's understand this with the help of an example. Let's suppose we have four values: 10,000, 9,000, 9,000 and 8,000. So these are four values arranged in descending order, starting with the greatest one, that is 10,000. So it will get the rank 1. Then 9,000 rank 2, but the third value is also 9,000. So we cannot say that this will be ranked as 3 because it is equal to the second value. So therefore we will give both the values rank 2. And now since we are repeating 2 twice, so 3 will be skipped and the value 8,000 will be assigned rank 4. This is how the rank function works. Here the missing third rank indicates that a tie occurred between values in the database. Dense rank function. Dense rank function also assigns same rank for ties, but it maintains continuous numbering. Conceptually, instead of counting rows, it counts distinct ranking values. So the dense rank function also works like the rank function, but the only difference is that it does not skip the next rank if two values have the same rank. For example, let's suppose if the first value has rank 1, second value has rank 2, third value is also similar to the second value, so there is a tie. So again the rank will be 2, but then the next rank will not be 4, it will be 3. This is the difference between rank and dense rank function. Analytic functions. Analytic functions allow row-to-row awareness. Instead of summarizing data, they expose relationships between rows. This makes SQL behave more like analytical software. So here we have examples of some analytic functions. First is lead function. Lead retrieves values from future rows. Conceptually, SQL temporarily shifts the window forward. Its syntax is lead, then in bracket column, comma, offset, bracket close. Now what are the uses of this function? It is used for predictive comparison. It is also used for time series analysis, future change detection and event sequencing. For example, we can use the lead function to compare current revenue to the next month's revenue. Next analytical function is lag. Lag retrieves values from previous rows. Conceptually, SQL maintains historical context. So the lag function works exactly opposite to the lead function. Using the lead function, we are trying to perform predictive analysis, while lag is used to get historical context of data. Analytical uses growth calculation. So yes, we can compare the historical data with the current data. Then previous state comparisons, detecting anomalies, change tracking. For example, we can use lag function to compare today's sales with yesterday's sales. Next function is first value function. It returns the first value inside the window frame. So first depends entirely on order by. What does it mean? If you are ordering the data in descending order, then the greatest value will be the first value, while if you are ordering the data in ascending order, the smallest value will be the first value. So first value in case of DESC keyword becomes maximum. So basically it acts like a benchmark or reference point. What are the use cases of first value function? It is used to compare with best performer, compare with starting price or baseline analysis. Last value function. This is exactly opposite to the first value function. It returns last value within the frame. Without explicit frame specification, last value function may return unexpected results because default frame often ends at current row. Therefore, defining full frame is very important while using the last value function. What are the uses of this function? It can be used to compare with final state, end of period analysis, and session tracking. Distribution function, NTILE function. It divides rows into equal buckets. Conceptually, it performs quantile segmentation. Instead of ranking individual rows, it categorizes them into statistical groups. Now, why distribution matters? Because it helps in risk segmentation, salary distribution, student grading, and customer segmentation. So basically, we are using the distribution function to divide data into equal rows, forming buckets of data. It helps us in simplifying complex data by creating segments. SQL distributes rows as evenly as possible. Frame specifications. A frame defines precise row boundaries within a window, while partition defines groups. Frame defines calculation scope. Now, what is the difference between a window and a frame? Window is just a logical group and frame is active calculation subset. Purpose of frame specification. It controls running totals, moving averages, local comparisons, and context-aware analytics. Without frames, SQL may use default boundaries which can change results silently. Types of frame. First, rows frame. Rows is based on physical row count, which means it selects rows relative to current row position. For example, rows between 3 preceding and current row. So it uses exact row numbers, and here the concept of rows is based on physical row count, for which it considers current row position as reference point. It is ideal for time series analysis, moving windows, and sequential data. Second type of frame is range frame. Range is based on value distance and not row position. It groups rows sharing similar order by values. If multiple rows have the same value, they are included automatically. Now, this type of frame is ideal for financial price bands, value clusters, and logical group analysis. Rows between. This clause defines start and end boundaries of the window frame. It allows precise analytical control. Now, here we have boundary theory. So first, unbounded preceding. It includes all rows before current. It represents cumulative history. Now, current row. It focuses calculations on present position. It is used for incremental metrics. Then end preceding. It creates backward looking window. It is used for moving averages and trend analysis. Then end following. It creates forward looking windows. It is used for forecasting or session evaluation. Unbounded following. It includes all future rows and it is often used in last value calculations. So today we explored window functions in SQL in depth. We understood what window functions are and why they exist, and how frame specifications like rows between control calculations. Window functions allow you to perform powerful analytics without losing your row-level details, making them essential for real-world reporting and advanced SQL queries. Now, to master this topic, practice it on the CodeChef platform. Thank you so much for watching.